Hello, friends, welcome. Friends, we all know that after 5G, the next wireless evolution is 6G. And India, from the very beginning, has started focusing on 6G and is now targeting to contribute 10% of the patents in the overall 6G portfolio. And this, our ministers have been talking for a long period of time, and we have already set up a Bharat 6G alliance to meet this objective. Now, all this is good. But as we move forward in the path of 6G development, it is also important to learn from history. So, in order to learn from history, we need to understand what happened when India started to develop its own 5G technology called 5Gi. I had already done a video on this topic, which gave you the nuances of India's innovation and how it did not map in the spectrum band which India tried to deploy this technology, which is 3.5 GHz band. This was just a copy of the innovation which was already implemented in bands which were above 6 GHz. So this video, I will paste the link of this in the description. You can go and watch. Now, friends, this was about the value of the technology. Now, today in this video, I am going to talk about the standardization process, how a technology is developed, and what kind of missteps India took in the overall technology development process. Means what they did at ITU and what they tried to accomplish in 3GPP. Now, before I go and try to explain to you about ITU and 3GPP, what India did, it is important to understand what these organizations are wanting to accomplish, means what their major objectives are. Now, ITU is called International Telecommunication Union. Now, International Telecommunication Union is a global body. The main aim from the point of view of wireless technology is to set up certain minimum standard of or criteria for evaluation of a new technology class. For example, in every 10 years, the wireless technology will always move to the next level, right? For example, we had initially 3G technology, then we had got 4G technology, then we'll have 5G, then 6G. So they call it, the next level of technology, for which ITU plays a very important role. So ITU is the mother organization which will work with all the countries, all the standard development organization, and ask them for their ideas that to what they see as a vision for the next level technology. And once they identify the vision, then they will set up certain minimum requirements, and those minimum requirements will become the foundation on which all the candidate technologies, which will be submitted by all the stakeholders around the world, will be evaluated. Now, ITU do not set up specification. The specifications are set up by standard bodies like 3GPP. So ITU only decide what is the visionary framework of a candidate technology for IMT Advance or 6G, right? It did it for 3G, it did it for 4G, did it for 5G. Now we are looking towards 6G, right? So what India did when it started rolling in the process of developing its own 5G standard, which is called 5Gi, they went to ITU with their initial proposal. Now, the concept was the following. Because whenever some country or any standard organization is making a proposal, it has to take care of its own requirements in-house. So India said that, look, we are a country where a lot of people live in the rural areas. We cannot afford to have a technology which will require a lot of base station, right? Base station densities are going to be very high in order to meet the coverage requirement of a sparsely populated area. So we want that the base station should not be of that high density so that the cost of both OPEX as well as CAPEX increases. So we would like to deal with the technology in a Indian context. Now, what is that? Typically, whenever a technology is developed, it takes into consideration all the user requirement scenarios. Now, user is not static. He is moving let's say in a car or in a bullet train. So when it moves in a bullet train, it moves at the speed of 500 kilometers per hour. Let's say that's the speed. So technology will take care of the worst case mobility scenario. So 500 kilometer per hour is considered for technology development so as to take care of all the noise emanating out of Doppler shift when the object is moving at very fast pace. Now India said that look, in our country, nobody in the rural area is going to move at 500 kilometers per hour. So we need our mobility requirement to be set at 30 kilometers per hour. And therefore, since our mobility requirement is going to be low, we can stretch the cell coverage, right, to such an extent that our overall tower density can go down. So that was the principal idea of India to promote a technology called low mobility large cell in ITU, and they did it on October 2016. So there was an initial proposal, and this is the initial proposal document right in front of you. This was the submission which India made on 20th September 2016, and this is the low mobility rural scenario, right? Now, so here when they made their initial proposal, no spectrum bands were identified. It was just a concept, okay? But later, in 2017, the LMLC evaluation framework got frozen in ITU. Now, whenever you freeze an evaluation framework, you need to take care of the performance criteria. Means what kind of data speed, what is the inter-cell site distance, and then what is the spectral efficiency, everything. And some of the requirements, or actually most of the requirements, are spectrum band specific. So they consulted India, and probably India wanted 700 megahertz band to be identified for the LMLC requirement. So 700 megahertz made a lot of sense in the rural area. So if you can stretch the coverage of 700 megahertz by a couple of dB or even double it, imagine the kind of base station density reduction that you can accomplish. So 700 megahertz band was identified with a frequency range between 450 to 960 megahertz, with an inter-cell site distance of 6 kilometers and the UE height of 1.5 meters. And the UE means handset antenna gain of 0 dBi, omnidirectional, and the power limitation of 23 dBm. Why 23 dBm? Because this is the maximum power you can transmit to not violate the SAR regulation, which is the electromagnetic field radiation, which may impact human body. So these were frozen into evaluation framework under 3 different documents. One was M2410, which were the requirements, M2411, which was the guidelines, and M2412 evaluation. How do you evaluate the technology? So I will show you one of the document. So this was the India's proposal. So this was the Indian proposal, and these numbers were set here. If you see that 700 megahertz was clearly here, and the UE antenna gain, etc. Everything is right here. And then we talk about this document. This is the ITU document of minimum requirement. You see, this is the minimum requirement on technical performance ITU document. And here also everything has been marked here. What is the LMLC, etc. Everything has been clearly. See, look, this is the recommendation for defining 8 key criteria of IMT 2000, which form the basis of the technical performance requirement presented here. And here, everything has been clearly set out, right? The speeds, etc. You can clearly see here. Look how much will be the downlink speed, what with outlink upload speed. Everything has been set here clearly. Then what happened in 2018? What happened was India was in the process of, evaluating its technology in the ITU setting. Because what happens in ITU is that every country will come out with every standard organization is going to come out with their requirements, and they may work towards creating their own radio interface technology called RIT. Now, once you have the RIT, then what happens? That does not mean that you are able to develop the product. So either you take your RIT to a centralized standard development organization like 3GPP, or you create your own standard development organization and use that to create your own specification, mapped to that RIT, which got stamped in ITU. Now, generally what happens is that nobody creates their own standard. Why? Because if you create your own standard, your products are going to be country specific. Handsets are going to be country specific. There will be no economies of scale and there will be interoperability issue. Your handset will not be able to roam in outside India. And then the prices of the devices will increase because India will become an island. So India always will try to integrate its own technology into a larger standard body, which is 3GPP. So India approached 3GPP. 3GPP said nothing doing, because if you really want to make any contribution, you come through our process. You participate in our meeting and contribute to our technology. So we are not going to accept anything which has been done outside the purview of 3GPP in a isolated setting. So that we will not agree. So India said that, okay, if they are not able to influence 3GPP, through directly, they went to ITU and asked ITU's help to ask for 3GPP to get to help them in the overall standard development process or integrate their technology in 3GPP, which ITU rejected. ITU said, no, this is not their role. They will only identify candidate technology. Collaboration of different standard development organization is beyond their purview. They do not want to interfere. So India could not get any help from ITU. Now, after having failed to integrate their requirements into 3GPP from externally without participating within their meetings, India had no other choice to submit its own RIT. Because India then went to ITU and gave a proposal of their RIT on the framework which already got decided, all the three documents which I had mentioned here. Look at these three documents, right? These are the documents. So these documents were already frozen. So on these documents, India then what India did? India submitted their technology and did self-evaluation. Now, self-evaluation is the process of telling that, look, we have evaluated the technology and this is the performance which the technology has able to meet. But that does not mean that ITU is going to accept what you have done and stamp the technology as radio interface technology, for the IMT, the IMT Advanced, which ITU is trying to develop. ITU will get the technology evaluated by the peers. So once they ratify, then only this technology will become a candidate technology, IMT candidate technology. But what happened was, interestingly, India changed the goalpost here. If you recall, though, friends, initially the evaluation criteria for ITU the RIT at ITU was in the 700 megahertz band. See the configuration of C of LMLC. On the 700 megahertz band, 23 dBm with an inter-cell site distance of 6,000 meters. But what India did was, it brought a new spectrum band called 3.5 gigahertz band, which was not there in the initial evaluation document. Because initial evaluation document was for 700 megahertz. And why did India do that? Because India later discovered that the technology which they want to implement, which is called pi by 2 BPSK, which I had explained in this video. You can go and watch this. This will only work in a TDD setting, not in an FDD band. And 700 megahertz was an FDD band. FDD band, you can't raise the power, which India wanted to raise from 23 dBm to 26 dBm, so that if you raise the power, then only the coverage will become high, right? It will be twice the power compared to 23 dBm. Now, if you raise the power to 26 dBm, what will happen? You will violate the SAR, which I told you, right? The EMF rules for human safety. So, but in the TDD, you can do so, because TDD, the transmission happens in a single block of spectrum where transmission as well as receive, right, is set for a certain ratio. Means the UE transmission, the handset can transmit only at a fraction of the time that the BTS transmit. Now, BTS is not a problem. Their power is not a problem. For handset, the power is a problem. So if you can manage the transmission rate, transmission time of the handset within that particular frame, then you can transmit at a higher power. Still, your overall power, average power, will be 23 dBm. So this is what India tried to do as per the 3.5 gigahertz band. They also change one more goalpost. They added gain in the handset. which made it almost like FWA-like. It would not support mobile handset because mobile handset do not have any gain. So first they increased the power to 26 dBm and made it FWA-like. So I'll show you the specification. So you look at this. This is the evaluation document of India. Look at this. This added one more page, 3 gigahertz band with a transmit power of 26 dBm with pi by 2 BPSK. Without pi by 2 BPSK, it is 23 dBm, right? So this is what India did. And it was not part of the frozen LMLC documents, which was already I showed you for the candidate technology for IMT, right? Now, when ITU evaluated, right, they made the following notes. They said that TSDSI is 3.5 gigahertz results are supplementary in nature. It is not part of the original requirements, means the frozen requirements. And then they said that declared not aligned with the document, the evaluation document. And therefore, it is not considered. The formal statement for ITU was no endorsement for supplementary material, which was an afterthought. So India did acknowledge that it was outside the scope, but India was helpless because their initial proposal was for 700, and all the technology innovation which they were trying to do were not applicable for the 700 megahertz band because it was an FDD band which did not support a higher power class. For higher power class, you have to go for TDD band, which was only 3.5 gigahertz spectrum. Now in 2009, India made another attempt because once they went to ITU, they failed, and then they went to 3GPP, and then again they went to ITU. ITU did not intervene. So now what they did was they made an appeal to 3GPP saying that, look, we would anyway come out with a technology which is separate, but these are incremental steps. These are not steps which are any very large, and it will not impact all the parts of the specification of the IMT technology. So since our changes in the overall 3GPP specification will be only incremental in nature, we would not like these changes to be on a standalone manner. We would like these changes to be integrated in the 3GPP specs. And therefore, if you reserve certain space in the 3GPP document and don't touch those spaces, we will be able to create a backward compatibility and we will continue to support this standard. But this was not the principle on which 3GPP worked. 3GPP said that anything which has been outside the 3GPP domain cannot be supported by 3GPP, and 3GPP is only responsible for supporting their own candidate technology, and therefore the proposal was rejected. And they said that bring this through normal 3GPP process. Now then, when the independent people evaluated India's RIT, which India submitted in ITU, they found that India's radio interface technology actually did not add any value more than what 3GPP already had. And even the delta changes were worse. There were no gain. And it added complexity. And the supplementary submission of 3.5 gigahertz band was summarily rejected because it was not part of the original evaluation framework. So from 2021 to 2022, TSDSI push into 3GPP, then they figured out some kind of a middle path approach. Then they went to 3GPP. TSDSI went to 3GPP and said that, look, we never wanted to make these features mandatory. Earlier, they were thinking of making it mandatory. Now, later, they decided to make it optional. Then, as some kind of settlement, 3GPP, said that, okay, we will incorporate your requirement in 3GPP as optional, but these are not going to be mandatory, and anybody who would like to implement these optional features can do so only if there are any demand or requirement from the operators, and the vendors and the OEM implementation will be dependent on that. Now, since there were no value which was clearly emanating out of the India submission, therefore what happened? There were no chipset vendor support, no OEM implementation, no operator demand, and the feature remained unused, right? So what are the outcomes and lesson? The outcome and lesson is, the first is, let's look at outcome. At ITU, the 5GI failed to show any unique value. It was like, same thing, packaged, old wine packaged in a new bottle. That's all. And later, when they changed the goalpost, realized that 700 megahertz cannot be implemented, they went into 3.5, which was actually a TDD band where they can raise the power to stretch the inter-cell site distance to certain level. But this was outside the scope of the initial RIT evaluation framework. So it was summarily rejected. So India changed the goalpost. At 3GPP, features were optional, therefore there were no adoption. In India, operator resisted, cost and roaming concern nobody supported, right? Globally, there is no ecosystem uptake because these features actually did not add much value. Lesson is that we need to first understand what we are aiming at. Once we have understood our requirements and what kind of technology innovation we want to do, we have to stick to those frozen ITU templates. We can't change the goalpost based on our whims and fancies. Then we have to do tremendous amount of value addition so that 3GPP is forced to accept our proposals. And we have to work within 3GPP. Working outside 3GPP through ITU will not add any value. Even if there is a candidate technology which we develop, we have to create our own specification, and 3GPP is a global organization, a global specification organization to ensure interoperability, roaming, and economies of scale of devices. If they don't accept our innovation, no value will be added because India doesn't want to become an island. And we need to work and roam outside. Our people have to want to roam outside India when they go out into other countries. So we have to show real value, and value has to be measurable, and we have to, our ambitions have to be aligned with practicality. So therefore, the moral of the story is when we talk about our 6G ambition, we have to learn from the past mistakes which we have committed. And this story, therefore, it is pretty important. And since these are extremely complex things, people who must be looking at and getting appreciating the government, look, government is thinking about 6G and they are claiming that India will become 10%, patents in 6G, and we have set up so many organizations, Bharat 6G organization, etc. They should realize that what kind of steps that we took in past and how we need to modify our steps in order to achieve success in the future. So that's all, friends, in this video, and thanks for listening till the end. And I will come back with a new video and a new topic next time. Thank you very much, friends.